All right, everybody, these are the notes for 4.4, which we're going to take a look at correlation coefficients, correlations, and line of best fit. So, thus far we have been graphing nice straight lines and working with constant rates of change. However, math in the real world doesn't always give us nice linear relationships to work with. So if we're looking at these graphs right here, okay, as you can see, a bunch of dots on this graph. This would be like data, so like real life points, and it's relating grade point average to hours spent studying. So this is kind of telling us that, well, if we don't spend a lot of hours studying, right, we're not going to get a high grade point, versus if we spend a lot of hours studying, we would get a high grade point. What this is called, because it's going in an upward direction from left to right, is called a positive correlation. The next one is saying, well, this one is saying, well, our grade point average would be high based on the hours of video games that we play. So if we play a lot of video games, we would have a lower grade point average, right? Versus if we spent not a lot of hours on video games, right, because it's lower in the y direction, we would have a higher grade point average. This, if we draw a line through all of these points, right, something like this, is called a negative correlation. And that's because it's going down from left to right. It has a negative slope. So this last one says the size of our television and then the average time spent watching TV. Notice you can't really draw a line up or down through this data because it's just scattered all over the place. So we can call these a couple things. You could call it no correlation. All right. You could call it negligible correlation. Negligible. I don't think I spelled that right. But those are the two things that we'll say if there is not a correlation. I prefer no. Easier word to spell. Anyway, let's talk about correlation coefficient next. Okay, so correlation coefficient shows the strength and direction of the correlation. So this is called the R value. The R value. And what it is it's a number between -1 and +1. Okay? -1 would mean a strong negative correlation, while +1 would mean a strong positive correlation. Anything in between changes the scale, right? This would be a moderate negative. This would be a weak negative. This one would be our no correlation, right? So there would be no correlation here if we're at 0. And then our weak positive, right? And then our moderate positive. So those would be the different types of R values. We're going to actually graph these in Desmos today, and it's going to be the value that says R is equal to. So the visual examples of correlation, right? A perfect positive correlation would look like this. Okay, because you could draw a line perfectly. This is our +1. Strong positive correlation. Okay, this is anything between 0.5 and 1 would be a strong positive. Weak positive is anything between 0.2 and 0.5. Or I guess up here it says that our strong correlation is 0.8 to 1. No correlation, that's between -0.2 and 0.2. Weak negative correlation is -0.2 to -0.5. And then our strong negative correlation would be -0.8 to -1. And then the perfect negative correlation is -1. All right, and that's just based off of this scale right above it. Okay, so if you don't have those memorized, not a huge deal. What we're concerned about are mostly these. Okay, because in life, that's what you're going to see most. You're going to see either strongs or no correlations, right? You could see weak correlations sometimes, and that's going to be more so when you're actually working with your own data sometimes, or something that might not have any correlation. But mostly we'll see strong positive and strong negative. Perfect is very rare in both cases. All right, Bryce collects data on the depth of a river at various points and the velocity of the river at those points. His data is represented by the graph to the right. What type of correlation does this scatter plot show? Well, it has some kind of negative correlation, right? Because, as you can see, the data is going down from left to right here. So we can for sure say negative. And if we're looking at how close all of these data points are, you could probably say it's a pretty strong negative correlation. So I would say strong negative. What would I estimate the correlation coefficient to be? Because it's strong negative, I would say probably about negative 0.9. It's definitely not like closer to perfect because we have this like kind of hump thing at the beginning here. But then it straightens out, so I'm kind of negative 0.9. All right. Anyway, that is correlation coefficients. What is a correlation? Next, we're going to go into linear regression. So this second page, I'm going to pull up Desmos to kind of walk you through the expectation of how to do a linear regression. We've actually already done this before, but it'll be really good to show you guys again. So in Desmos, you can have the app. You could open Desmos up on Safari. Either one will bring you to a page that looks like this. So what we're going to do to make a line of best fit or a linear regression is we're going to click the plus sign. Okay. As soon as you click that plus sign, we need to have a table. Okay, so we're going to open up this table. In this table, we're going to put all of the McDonald's data here. So it's telling us that different McDonald's sandwiches have different total fat and total calories. Usually in a graph, the column on the left with the numbers is going to be your x's, and then the column on the right is going to be your y's. So that's kind of what we're going to stick to for today. Honestly, though, it would not matter as long as you make sure that you understand the variables. Okay, but I'm going to put total fat on my x, total calories on my y. So if we just enter all this data, we have 9, and then 12, and then 23, and then 19, and then 26, 42, 29, 39, and then 40. And then we have 18, 16, 26, 18, 16, 26. And then we have 9, 22, 17, 10, 15, 17, 10, 15, and the last one is 9. Okay, so that's all of our x's. Now we have to enter our y's, which are going to be the total calories. So that's 250, and then 300, and then 440, 390, and then 510. And then we have 740 and 540, so 740, 540, 790, and then 750, 770, 380, 360, and 500, 510, and then 340, so 510, 340, and then 270, I got off somewhere, 22 should have been 510, 9 should have been 360, so 9, we're at 360, 22 is 550, or 510, 17 is 340, 10 is 270, 15 is 330, and 9 is 260. Okay, so there's all of our points. Awesome. The next thing we need to do is we need to be able to see all of these points, because if you notice on the right, we actually can't see any of these points. So in order to see the points, we need to go to the settings, okay? And we need to change the x-axis. Well, the lowest value in our table for our x's, or our total fats, is 9, okay? So in my opinion, it's good to see the y-axis, so I'm going to make the lowest thing -5. I'm making it -5 because there's nothing past 0, so I don't need to go very far negative in the x direction. For my x maximum, though, or the biggest x value that I want on the x-axis, the biggest one in our table is 42 for the total fats. So we need to go a little bit higher than that to make sure we see it. So probably 45 is going to be good. Okay, step would say, what do you want to count by? You could just count by 1s, count by 5s. It doesn't matter. Okay, I like counting by 5s. That'll be nice. On our y-axis, you can see that, again, these are really high numbers. So probably just -10 is fine for the y-axis minimum, so that we can see that y-axis. For the y maximum, or this number on the right here, we need to make sure we see the biggest number on our table. So the biggest number, 790, is what it looks like for the Angus bacon and cheese. So 790, so I'm probably going to go 800. And honestly, it's probably going to be good to count by about 100 for here. If you want to make sure you're seeing the y-axis, it might be good to go -100, just to make sure you can see it. And then if we close this, check it out, now we can see all those points, okay? If you want to bump it out a little bit more so you can see those ones on the top right, you could, right? So we could go out to 50, we could go up to 850, just to make sure we see everything nicely, all right? And there's our data points. So we have all of those things entered. Next, we need to build our line of regression. So we're going to go down to the second line, like right below the table. We'll just click in the box. And then what you need to do is you need to go to y, so this y right here, and then you're going to put y1, right? And then, see how it says 19 elements in the list? That's talking about our list, or our table, right there. Next, we need to go to our squiggly. So the squiggly is down here, so squiggly line. And then we need the slope. We want m is our slope. And now we need to go to x1, so x and then 1. And then the last thing in our slope-intercept form equation would be plus the y-intercept, so plus b. All right, and then as you can see, it builds a nice, beautiful line straight through this graph. And it actually gives us a ton of data here. All right, so this data in this table, as you can see, it gives us the r value, it gives us the m, which is the slope, it also gives us b, right? It gives us our projected y-intercept for this graph. So the first question says, what is the equation for the regression or line of best fit? Round any decimals to the nearest 10th place, right? So our equation, because we're writing in slope-intercept form, is going to be y equals, and then it said that our slope was 15.7569, so if we round to the 10th, that would be 15.8. So we say 15.8 m. And then our y-intercept is 114.322, so that would be plus 114.3. All right. Next, it says, what form is the equation in? Well, it's in slope-intercept form because that's how we wrote it. All right. And then it says, rewrite the line of best fit equation into the following two forms. So it wants us to rewrite it into point slope form as well as standard form. Sorry, I'm realizing that in this line of best fit I wrote 15.8 m. It should be 15.8 x. I don't know what I was thinking. I was thinking slope. So if we want to write this into standard form, that's probably the easiest one, right? We need to subtract 15.8 x from both sides. So that's going to be negative 15.8 x plus y is equal to 114.3. All right, it is for it to be in standard form, we need to have positive and no decimals, right? So we're going to multiply all of this by -10. That's going to be 158x minus 10y is equal to 1,143, right? And you could find probably a number that is divisible by all of those things. Actually, I'm not too sure. 1,143 might not be divisible by anything. But we're good right here with standard form, right? This is positive. There's no decimals anymore. So that's a great stopping point for standard form. If we want to write point slope form, we have a little bit more work to do, okay? So we need to go here, and really we just need to find a point. Well, to find a point on this line, you actually can just drag your cursor along the line here and look for a point that's nice, okay? It doesn't have to be beautiful, right? We can just round something to a 1/10. So like, I don't know, let's just use, we'll use something right here in the 20s. So 20, 429.459. So that's going to be 459 would be 0.5. So 20, 429.5. So the point that we're going to use is 20, 429.5. So then we need to write y minus the y1, which is 429.5. Don't need parentheses there, is equal to the slope, so 15.8, times x minus 20, because that's the point that we used. And then there we go, that's point slope form. So you just need to follow the line until you get a point that you like, and then you can just write that in. All right, so what is the correlation coefficient? Well, the correlation coefficient is the R value. In this case, the R value is R is equal to 0.978. So 0.978. Remember, it's the one that is R equal to. It's not R squared equal to. Okay, it's the R equal to. What conclusions could we draw about this data? Because it's in the 0.9s, right? It's really close to 1. This is a strong positive correlation. And strong is just saying how close the data fits the line, right? So we can say the data fits close to the line. Right, so the data fits closely to the line of best fit. The last thing it says here, it says approximately how many calories could a sandwich with 35 grams of fat have? So how are we going to do this? We're going to draw a line right at that 35, right? So it's saying grams of fat, 35 grams. This is talking about an x value, right? X equals 35. It's wondering what the calories is. What is y? So calories equals y. It's asking us for what that y value is. So if we actually just type in Desmos, which this is awesome, if you just type in x equals 35, it builds that vertical line, and then it shows us the point where it crosses our linear regression. So as you can see, x equals 35 is going to cross right at 665.8 calories. So then approximately how many? Approximately 665.8. Okay, and the squiggly equal sign is approximately. So that's how we say approximately. Also, we should probably put the units, so CAL for calories. All right, if it asked us a question like this, approximately how many grams of fat is a sandwich? Let's actually do this question. Is a sandwich with, I don't know, 272 calories? Now we need to say, okay, we know that y equals 272. So we're going to go to our graph. We're going to type in y equals 272. And then bam, right there. Approximately 10 grams of fat. So approximately 10 grams of fat. All right. So those are the types of questions I would ask after having you guys do a linear regression. As always, guys, if you have any questions, please feel free to message me on Canvas, or, do whatever you need to do to contact me. I know this can be tough. That's why I made this video, to show you guys how to make linear regressions in case you don't catch all of it today in class. Have a great day, guys.